Okay, so we're going to be introduced to inequalities today. Um, and so the first part, and again, you guys are just going to take the notes with me, follow along, and then, whenever it's time for you to write something, pause the video, write it down, and then restart the video wherever you left off, and just keep going like that. That's the easiest way to get all the information and get through the video as efficient as possible. So the first part is asking what is an inequality. Okay, so an inequality says that two values are not equal. Okay, so there's two sides to an inequality. There's like it's the part where you have 4x plus 1, for instance. That's saying that that's not equal to whatever is on the other side of the inequality sign. So anyway, it's mainly in a nutshell, it's saying that two values are not equal, and that's the most important part, is the fact that they are not equal. Okay, if they were equal, we would say, oh, it's an equation, because equation means that they're equal. But inequalities does not use the equal sign because they are not equal. Okay, so if you had 2 on one side and 2 on the other side of the equation, those are equal amounts. It's an equation. But if you had 4 on one side and 2 on the other side, those are not equal. So that's an inequality, right? So that's what an inequality is. So instead of using the equal sign, we use inequality signs. And you guys are familiar with these already, but I'm going to review them. So the first one is the greater than sign. Okay, so we read from left to right, meaning from here to here. So this would be like 8 is greater than 4. You wouldn't go the other way if 4 is less than 8. You read from left to right, so 8 is greater than 4. The next one is the less than symbol. And we, again, left from right, 2 is less than 6. That's an example of that. So we have greater than, we have less than, then we have greater than or equal to. So it can be greater than that number, or it can be equal to that number. So greater than or equal to whatever number we're talking about. And then, of course, we have less than or equal to. It can be less than this particular number or equal to that number. And so those are the 4 inequality signs. They're greater than, less than, greater than or equal to, less than or equal to. So next part is, what do they look like? What does an inequality look like? What does it look like? So first of all, we have 4x plus 1 is greater than or equal to 11. And if you notice, it has a coefficient, and it has a variable, just like an equation. And then it has a constant here, just like an equation. And then over here we have a total, just like an equation. The only thing that changed was this right here. Instead of saying it's equal to 11, we say it's greater than or equal to 11. So it can be equal to 11, but it can also be greater than. So what this is saying is that this value, when I input that value, the answer I get when I do 4 times whatever this value is plus 1, that answer is either greater than or equal to 11. So if I solve this and I get x, whatever x gives me is going to be greater than, whatever x gives me and I plug it in, it'll be greater than or equal to that number 11. So we can solve it to figure out what x could be, right? So we can have 4x plus 1 is greater than or equal to 11. And so to solve it, you do it the same way we did equations. We would subtract 1 here, subtract 1 here. Now they're not equal, obviously, but it's the same theory applies. Whatever I do to one side, I need to do to the other. So if I subtract 1 over here, I subtract 1 over here as well. And so what happens is you bring down the 4x, and then 11 minus 1 is 10. So now I have 4x equals 10. Now I divide here by 4, I divide there by 4, so x equals, you can simplify it to 5 over 2, or 2.5. So you may be thinking, well, that x is not greater than or equal to 11. No, but if I plug this x in, if I put this x into my equation, then that answer is greater than or equal to 11. So to test it out, I can say that 4x plus 1 is greater than or equal to 11. I plug in 2.5 here, so 4 times 2.5 plus 1 greater than or equal to 11. And then I do 4 or 2.5 times 4. 4 times 5 is 20. 4 times 2 is 8, plus 2 is 10. And then we have a decimal here. So 10. So 10, 4 times 2.5 is 10, plus 1 is greater than or equal to 11. And then 10 plus 1 is 11, greater than or equal to 11. So I look here, is 11 greater than or equal to 11? It is. It's equal to. So whenever I get this number here, I plug that back into my function, and that'll tell me whether or not what I'm saying is true. And it is true that when I plug it in 2.5, I get 10. 4 times 2.5 is 10. I add the 1, I get 11, which is greater than or equal to 11. Now you may be saying, well, I thought you said they weren't equal. Well, the deal with inequalities is the only possible answer is the 11 isn't the only possible answer. Okay, 12 could be a possible answer. So what I mean by that is I can put, instead of 2.5, I can put 3 into that function. And 4 times 3 is 12 plus 1 is greater than or equal to 11. So what we do is we put 11, we put this number 2.5 on the number line, right? 2.5. And then we say that any number greater than 2.5 is a possible solution to this function. Okay, so in class, we're going to discuss much more about what it means to be a possible solution. We're going to discuss much more about number lines. We're going to discuss much more about the inequality signs. But I do want you guys to know that the way you solve them is to treat it like a two-step equation.